Okay. I'm going out and come back, okay? Okay. Now say something.
Hello?
Yeah. Okay, I can hear you. Great. Who was that?
Saad?
Oh, okay. Hi, Saad.
How are you
Okay.
doing?
Sometimes you have to go in and out. That's what happens. Okay. So since everybody's here now, the first thing I wanted to discuss is about the project. Okay. Everybody ready?
Yes.
Okay. All right. So the project you already know is the question 9 from chapter 5. And I wrote down in detail what are the things you are supposed to do. Let me state that again. Okay. Now, first of all, I gave you a data modeling sheet. I put it on in the announcement, and I hope everybody can look at that data modeling sheet. Okay, so what's the first thing you're going to do in this problem? Well, the first thing you're going to do is write the business rules. Okay, when you write the business rules, make sure you don't write in simple sentences. Okay, make them simple. Don't make them too many things in it. Simple, maybe single sentence. Okay, so write the business rules. There could be many business rules. It's better to have many simple business rules than to write down few of them complicated. Okay, remember that. So once you have the business rules, the second thing you can do is write all the entities. You're going to get all the entities. Okay, once you got all the entities, you have to write their attributes. Also remember that you also have to write the primary key for them, each including the primary key. Oh, just don't worry about primary key, just say key. Key for each entity. Once you have done that, you got to go and look at all the relationships. Okay, and then you write their attributes also. So once you got all the entities, you got their attributes, including the keys, you got the relationships, and you got their attributes. Okay, now you also have to look at, when you look at the entities, you have to also look at which entities maybe you might want to have super and sub-entities. Okay, so having super types and subtypes. Super types and subtypes, their attributes, relationships, and of course, keys. So once you got all this, once you got all this stuff, okay, you can draw, now you can draw ERD. Actually, it's not ERD, it's ERD. Okay, this is what we call extended come on. Okay, let me fix this. Okay, so we have extended ERD, okay? What does extended ERD means? You have regular ERD, and then you have ERD where you have super types and subtypes, and that's called extended ERD, okay? So remember that. So this is called extended ERD. Okay, so once you got that, now you can write your schema. Okay, and then we are going to talk about it, and we're going to show, after writing the schema, you have to create a database, and how do you do that? Okay, so
Professor, don't we have to do the relational diagram before we do the schema?
Okay, thank you. So let's put that here. I just assumed that. Thank you. I'll make it prime, 5 prime. Thank you. So do the relational diagram. Okay, so what is in the relational diagram? Especially what you have to show, we have to show, okay, we have to reduce n by n relationships, right? Many to many relationships into one to many. Okay, and one more thing we have to do here. We have to show all other relationships using foreign keys. Show all relationships using foreign keys. That's the main use of the foreign keys. Okay. And once we have got schema, then we are going to be ready to create a database, and we are going to talk about that. Okay. And that's where we use create statements. Okay. So once you have that, once you create the database, we're going to use MySQL as the Dbms, and we are going to create your database, and then you can also populate with some data. This data also, you are going to create this data, okay? That's what you're going to do. You're going to come up with this data. And then lastly, once you have the data, okay, and we will use something called insert statements. And then you can write some, let's say, come up with 10 queries. And you can run these queries. You're going to submit all this, all the things you have done, you will be submitted in a report. Okay, now remember, this carries big amount. It's 15% of the grade. 15%. That's a lot. And you are able to do it with another person. And you go to submit only one copy, not two copies. 15% of the grade, you submit only one copy. Okay. Now there is one caveat here, which is you can get help from me. Okay. Because it's very important that you go through those whole exercise, and in the end, no, there's no example project. Okay. Well, you've been doing EERDs, so that's the example project. Okay. Okay. So the most important thing here is this. I would like you to do the project correctly, so that all of you can get 15%. Okay. That's not the only aim. The aim is that you go through the thing and you learn the whole thing, the whole process. Okay. Now, we didn't talk about here that these relations are in normal form, but you are going to check whether the relations are in normal form. If the schema is normal form, okay, we'll check that. Okay. If the schema is in normal form, we're only going to check in third normal form. That's it. That's all we need. Okay. So as I said here, that I will be available to each group separately. Okay, so I will be able to each group individually. So you got to start cracking fast, because otherwise, there are too many of you. I may not have enough hours. Sometimes I might have to meet with you on the weekend, okay? All right. So the goal is that all of you learn that goal. All of you go through this correctly. That's what I want you to do, okay? So that you learn how to apply all this you have learned into your project. Okay, let me ask you this. This is very important now. How many of you have watched the video?
I watched most of it.
Okay. Okay. What about other people? Send me a chat or say something.
I didn't watch it.
You didn't?
I didn't have a chance yet. I started watching it, but I didn't finish.
I plan on watching
You
it.
have to watch it because there is no time. Because I am going to assume that you have watched it and I'm going to go from there. Okay? Watch it. Watch. You're going to have to watch it tonight or tomorrow. Okay. Before we go there, any question regarding the project? Now, it's going to be very crucial for you to write the business rule correctly so that everything which is asked no, you cannot combine. Okay? All right. Okay. Now, it's very important that you write the business rules. Spend the time on the business rules. Because if your business rules are not right, then nothing else is going to be right. Okay? Because business rules are going to dictate a couple of things. What data is going to be in the database, business rules are going to dictate. Number two, business rules are going to also dictate what kind of questions you can ask. From your data. Remember, when you're taking software engineering, we are talking about their use cases. Well, those are the use cases. How the database is being used. Well, if the database is incorrectly created, then how it can be used properly? It won't be used properly because it won't answer the question you have. Okay, let me give you one hint to start out. In the database, in that question, there is an editor. Okay. Now, editor is able to do anything during to the database. Any question the editor can ask. So do not connect the editor to anything. Okay, there's only one editor for the whole journal. So put the editor on the side on the picture. Okay, then that is not ready. You are not ready for that anyway yet, EERD. But I'm just telling you that the editor will be sitting on the side and be able to ask any question from the database by having a query. Now, okay, so you may think that there is a lot of time. There isn't a lot of time because you are taking other courses and we still have a lot to do in this course too. Okay, guys? Now I want to hear from you guys. Any questions? No question. And read the, I have actually, whatever I have said here, I said the same thing. The sooner you start with this, the sooner you can meet with me. Okay. So actually,
better.
yes,
I just wanted to ask how many people are going to be in the group?
2.
Okay, thank you.
No more. Okay.
Okay, thank you.
I will just tell you that please start right away. Also, make sure you actually see the video. We haven't got enough time now to, go over everything. All right. Okay. If there are no questions, I do want to repeat something which I have said before, but some people, it didn't make any difference. Okay. So I'm just going to put it here. Okay. So this is regarding the assignment 11. Okay. So this is the assignment 11. Okay. Let me just do one question, and then you guys can make sure, because there is going to be a quiz on this. Okay. If we give a quiz, it's only good for you, because this question is going to be on the final also. Okay. So if this question is going to be a final, whatever assignment 11 is, exactly the same question will be on your final. The only thing will be the same question, and you got to pay attention. Okay. So let me just go over something where people are really, some of the things which people are not doing correctly. Okay. All right. So let me just go over this question here first. I'm going to go over this question, the second part first. Okay. Question 2 has A, B, C, D, and E. Okay. I'm not putting commas. I'm just going to write this like that right now. Okay. And we are given AB determines C, C determines D, and D determines E. Okay. C determines D, and oh no, functionally determines, okay, and E determines A. Okay, now let's look at this question. Oh, here. So anytime this question will be given, we will be given a relation with this scheme. I should have put commas here, but I just want to write it fast. So R is the name of the relation. These are the attributes, and these are the functional dependency. That's what will be given to you. And the question will be worded exactly the same. Now find all the keys, not super keys. That's the number we're looking for. Find all the keys. And then we are going to ask the question again. Is it in third norm form? Is it Bossico norm form? Is it third norm, second norm form? Now, I told you before, I didn't want you to use any other definition other than I gave you. Okay? I gave you the definition of third norm form, second norm form, and Bossico norm form. Okay? So let me, I will remind you when we just go through it. Okay? So first thing we wanted to find out is, okay, what are the keys here, right? Now, we did give you an idea that it looks like if you look on the right-hand side, there's no B, so B is going to be part of every key. Okay? All right. So let's look at what's the, if we want to look at first, what's the closure of AB? Closure of AB, everybody, is equal to AB, and then you can get C from there. And then from next, you can get from C, you can get D, and next from D, you can get E. Okay? All right. So it looks like B is going to be part of everything. All right. So if we want to get A, we can get it right from here. Looks like we can say BE will be also a key. Let's see first. What is the BE? Is equal to BE, and then we get A. Well, once you got AB, we already know that we are going to get everything else, because now you got AB, you're going to get C, then you're going to get D. Okay? You got everything. Now we can see that we could try to combine B with everything. Let's say B with D. Okay? Now what we get? We'll get B, D. From D we get E. And from E we get A. And that's it. Now we got C. From D we got E. And from AB we will get C. Okay, what else? We can also try BC. Okay, what do we get? We start with BC. From C we'll get D. And once we got D, we got E. Once we got E, we got A. Okay, so we showed the closure of ABB and all this. But now the problem is we have to show that each one of them are actually minimal super keys. We know these are super keys, but we have to show they're minimal. Well, it's very easy to show because we can check what is the closure of A. What's the closure of A, guys?
A.
A, that's it. And what's the closure of B?
B.
Nothing, B. And what's the closure of C?
C.
No,
And D.
C and D.
and D.
C and D and E and
A.
A. But we didn't get B. Now, what's the closure of D? It starts with D, then we get E, then we get A, and what else?
That's it.
That's it. So we show that A, B, C, or D, or E, they are not, okay? And we can check E too, by the way. Sorry, we forgot to E. What's the closure of E? What's the closure of E?
E and A.
E and A. That's it. Okay, so we saw that if we look at any one of these separately right here, none of them is a super key. So these are minimal super keys. The other thing you have to do, which a lot of you didn't do, okay, we have to write down what are the primes. What are the prime attributes? Well, all the one on the left, which are part of the key. A, B, C, D, and
E.
what are the non-prime? What are the non-prime?
Nothing.
They don't have.
Empty. Okay, now this thing I think you guys forgot. Okay, let's just look at it. Okay, let's look at this right here. If I have here, oh boy, I got to do this again. Okay, if I have here left hand side, now let's look at the definition of third normal form. What was it?
Left-hand side is either super key or right-hand side is a prime.
Prime. Okay. Now, everything is prime here. So is there any question of even checking anything? No. If everything is prime, the relation must be in
Third normal form.
third norm form. Even if the left-hand side is not a super key, the condition says the right-hand side is prime, but everything is prime. Similarly, here, we say X A. Okay. So over here in the second norm form, please listen carefully, okay? In the second normal form, X is the left-hand side, and this A is on the right-hand side. We are saying this right-hand side is partially dependent on the left-hand side. But what is A? A must be non-prime. If this is not a non-prime, you don't check anything. So what does that mean? If there is no non-prime, it is automatically in second normal form. You got to remember this, that the third normal form and the second normal form have problems if you have non-primes. If there are no non-primes, then by definition, it is in second normal form and third normal form. You don't have to think anything more. Any questions, guys? Please remember, if you don't give a reason, then you don't get any points. Now, what about Bose-Einstein normal form? Every left-hand side must be a super key.
Super key.
Well, you have to only show one. C functionally determines D. C is not a super key. You don't have to say, oh, D, E, and all that. When you are trying to disprove something, you give one counterexample and stop. Don't waste your time. Okay, let's look at the other, the first one. There also, a lot of people are saying things which are not make sense. Okay, so we have there A, B, C, D, E, F, G, H. Oh my God. A, B, C, D, E, F, G, H, H. Okay, now I'm going to be short in here. It says A determines B, C, and D. So I'm just going to write that down here. I'm just going to write down A determines, of course, A will determine A, right? It's also determinant. A determines B, A determines C, A determines B. And then I have here AE determines B, and AE determines H. Then I have okay, now let's just look at this quickly. If we get a pointer here, so A determines B, A determines C, therefore we can say A determines B, C, D, right? So we can say that here, that A determines A, B, C, and D. Right? Does A determine anything else? No. But A determines A, B, C, and D. Now, if you notice it, that you really need either E or F, one of them. And then you will get, just notice here, if I have F, I will get E. And once I got E, I will get H and I will get G. So either I have here, I take AE and find its closure, I'll get everything. Or I take AF and find its closure and I'll get everything. A, B, C, D, E, F, G, H. Same thing here. I'll get A, B, C, D, E, F, G, H. Okay. Now we already showed here. Please look at it. We already showed that A is not a super key right here. So if A is not a super key, then it's AE is a super key. So that means if we take E out of it, it's not. Okay. Now we just have to show what is the closure of E and F. Okay. So what's the closure of E and F? What's the closure of E? It's just E,
EF.
EF. And what's the closure of F?
FE.
FE.
Right? Okay. So we have to prove that, okay, that either remove from here A, we left with E, and here we left with F, and they are not super keys. And A alone is not a super key, therefore AE and AF are super keys. Okay, so now it's very important to first write down what is prime and non-prime here. Okay, so what is prime and what is non-prime? Prime are just, what are the primes?
AEF.
Prime is A, E, and F, right? And everything else is non-prime.
Non-prime.
Remember, A, E, and F were okay. Now, the question is this in third normal form? Well, it's not. Just look at one of these things here. A function determines B. A is not a super key and B is not.
It's not prime.
That's it. You don't have to look at any of these things. But okay, some people say this here. Okay, F determines E. F is not a super key. But remember, E is what?
E is prime.
Prime. Same thing here. E is not a super key, but F is prime. So these two do not fail the condition. Neither this. These fail the condition because this is not a super key. This is not prime. Not a super key, not prime. So not a super key, not prime. Some people are showing me this. Okay. Again, it's not in second norm form. Why? This is another problem people don't understand. Okay. All right. Second norm form. The second norm form definition is as follows. Okay. Let's say X actually determines A something. Okay. X function determines Y here. Don't want to get it. Okay. Now, If you want to look at this and say that it is not in second order form, then why, first of all, you have to look at it as a non-prime. Then X has to be part of a key, because then it will be a partial function dependency of a non-prime on X, which is part of a key. But look over here. If we look at A determines B, let's look at that. A functionally determines B. Then what do we say here? Well, A is part of a key. Which key? It's a part of AE or AF. Doesn't matter which one. It doesn't matter. A is part of a key, and B must be what? B is non-prime. So now what do we have? A non-prime is dependent on part of a key. Therefore, it's not second order form. But you cannot you can't say here. You see, this is another thing people saying. F. Okay. Oh, E is part of a key. Of course, E is part of a key. But F is not non-prime. So this will not do the job. Again, you have to only look at one of this. If this is a part of a key and this is non-prime and is partially functionally dependent, then that is it. That's the second order form. Now, I told you guys that if something is not second order form, you cannot use the fact that it's not going to be in third order form or second order form. I told you before. So don't do it. Some of you are doing it, but you will not get any credit. And also, you can't say, oh, third order form, second order form, second order form, without any reason. And a lot of you are doing that too. You won't get any credit. Also, on this problem, okay, all these problems were there for you to think a little bit so that you get an idea of what's going on. So in the last problem, we had here, what was it? Oh yeah, R S I D M. Now here, which we said that SID determines D. And XD determines M. Okay. Now in this case, let me explain this also. Now, if we take SID and find its closure, what do we get? Well, SID D, because we have SD, therefore we'll get M. Yes? What's the closure of SI? What's the closure of SI?
SIDM.
SIDM. And what's the closure of SD? SD and M.
SDM.
We can write it down here. So SI closure is SI D, and then from SD we'll get M. And the closure of SD will be equal to SD, and then on the right hand side you get M. Okay. So that means we have only one key right here. That's it. Now, what are the things which are here, prime and non-prime? Well, the prime is S and I, and non-prime is D and M. Now, if we want to look at whether it is in third normal form or not, we look at this one. Oh, this is key, super key, so no problem. Oh, here, by the way, you can check the closure of S is S and the closure of I is I. Okay. In this case, of course, we are not even given SID with anything. Okay. In any case, this is super key. That's enough. And then you look at this. This is not a super key, and this is not prime. So therefore, it's not in third normal form. What about second normal form? Well, look at it right here. D is non-prime, but is it dependent on part of SI? No, it's dependent on the whole. What about M? Is it dependent on part of SI, S or I? No, M is dependent on SD. So therefore, it is in second normal form. So don't let it confuse you. Also, if you want to disprove something, please give one counterexample and go on. Okay, to the next question. Don't spend your time. Okay? It's important. It's very important for you to get the definitions correct. And of course, Bosic or normal form, everything is very simple. All left-hand side must be super keys. Well, this is super key. This is not a super key. So this is not in Bosic or normal form. Okay? Any questions on this, on 11? Okay. Anybody else? Anybody else has a question? It's very important. This is important for the quiz. This is important also for the final. Because you will get a question just like this. You will be given a relation, you will be given functional dependencies, and you will be asked to find all the keys. And remember, there may not be 1 or 2 or 3 keys. There could be 4 or 5 keys. So don't think that, oh, I found 1 key or 2 keys. Then all keys are done. No, there could be a lot more keys. Usually, if I'll give something on the quiz or final, I might give something with several keys. So don't be fooled. You got to give all the reasons. Anything you do, justify it. And use the definition I gave you. Don't say something is on a second normal form, therefore it's not in third form or Bosic or normal form. No. One more thing which I didn't mention before. Every relation by definition is supposed to be in first normal form. So there is something called first normal form. Let me just write this down here. There's something called first normal form. Then what the heck it is? Okay, so first normal form. Okay. All right. First normal form just means the following, okay? Anytime you have a relation, there are rows, sorry. Okay, so if you have this relation, and let's say these are attributes here, just call them here, A, B, C. Okay, so what it means simply that everywhere here, every cell has a value. That's all it says. Okay, there's a value, single value in each cell. Okay, that's in first normal form. So by definition, we have a tuple here, tuple here, tuple here, tuple here. Now, sometimes some of these values are not known, but you can still use a placeholder or something, okay, to satisfy the definition. So everything is non-null, and then there's a value in every place. That's all it means. That is first normal form. So every relation, by definition, is in first normal form. Okay? That's all. Okay, I'm going to move on to something else. If you don't have any questions on this. Okay, now, all right, so I just wrote something here and I'm going to talk about it. So what we want to talk about is, I'm going to have to rewrite it anyway. Okay, so what I want to talk about today, whatever time we have, is SQL. SQL also stands for, you see, it is a language designed by IBM. Okay, and IBM designed it for a relational database called R, and they called it a SQL. Okay, SQL, and even a lot of people still pronounce SQL as SQL because it's easier to say than SQL. Okay, now let me mention a couple of things about it. Number one, it's a query language. What does that mean when we say it's a query language? That means it only makes a statement about what it wants. You know, what's the result it's looking for. It's not telling you how to do it. Well, if you remember, relational algebra actually is algorithmic language or procedural language where you have to tell whatever result you're trying to get, how you're going to get it. Here you only make a statement of what you want. Okay, therefore this language is also called declarative language. That means you just declare what you will like in the result. Okay, so it's called declarative. Okay, and you can say it says about what, not how, and it is also called the declarative language. Another thing is about, it's case insensitive. So you have keywords here. So for example, over here, keyword select, project, select from or where. Okay, now let's just go back and remember, in relational algebra we had keyword select, we had keyword project, maybe keyword join and all those things, natural join, blah blah blah. How come there was a select in relational algebra? There's a select here too. Well, let me tell you this. This select has nothing to do with relational algebra abstract. This is like saying going to a store and let's say you go to the drugstore or something, or go to a grocery store, or no, maybe you go to buy bakery or something. You tell the person, oh, I want so many cookies, I want this, I want this cake, blah, 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 blah. Okay? And that's what select here says. Give me these things here, A1, A2, AN in the result from these relations. Okay? This is what I want. These are the relations. And this is the condition I have. Okay? This is also called the filter. Okay? So in any case, this select has nothing to do with the relational algebra select. So please don't confuse it. Some of you asking when they were doing relational algebra, they are telling me select here. They are writing select from where? But this is SQL. That's not what we asked you. All right? One very important thing about this, as I said, is case insensitive. So these are the keywords. Let's say select, from, and where. You can write them any way you want. They are case insensitive, but I suggest strongly you put them in capitals so you don't confuse the keywords of the language with what you write. Okay? Now, we are going to look at this thing which we already have, our database. Now, remember this, as I told you, you have to go over those videotape 4 hours, because I am going to assign you a question now on this. And you are going to, after the watching the video, you will be able to do that question. If you don't do the video, you won't be able to do the question. It's going to be just one question. So please, I'm going to give you a question on this. Okay? He's going to show you in that video how to create a database you want, and then how to populate it, and then you're going to answer the question. Okay? So please watch it. Okay. Any other question on this? Because I am going to erase this because I need the board now. If anybody has any question, please ask right now, and then I'll go to the next board. No question? Anybody wants to take a copy of this? Otherwise, we go to the next one, okay?
I already took a screenshot of it. Thank you, Professor.
Okay, all right. So let's go on, and let's see. Okay, all right. So as we said, so maybe use the blue. Okay, so you can say that SQL is supported by all DBMSs. Okay, of course, everybody says, "Oh, we don't want to sell you vanilla. We want to make it chocolate or sprinkles on it." So they may do something. You know, every vendor might be trying to do something, but basically they all support SQL. Okay, now, so it's a there's a standard for this. It's a standardized. Okay. Okay. So of course, many thousands of pages of the standard. Okay. Many pages. Okay. Now, You can use it many different ways. You can use it interactively by using GUI, or you are going to use it by prompt. Okay, so you are going to use it mostly right now by prompt because you will learn more about it than if you did otherwise. Okay, all right. Now, many times, as we said before, it will be embedded in other languages. Okay, maybe you're calling it from Java or whatever. Okay, Java, no, Java, C++, whatever. Okay, now one thing I want to mention to you, that SQL sits on the top of relational algebra. Okay, well, let me spell it out. What does that mean? That anything you write in SQL, it will be translated into relational algebra. Then there will be a optimizing compiler, and then they will optimize it, and then they will execute it. Okay, so you can write anything you want, and it will take care of it. Okay, all right. Now this language, it does many things. Okay, it's what we call DDL. That means it's a data definition language. What does that mean? Now, what that means is, when we doing the project and when we have the data, we are going to use something called create statements to define the data. Okay, that's why it's called data definition language, and is also called data manipulation language. Why? Because we will be able to manipulate our data using SQL. Okay, so that's called the data manipulation language. And when we are talking about, we will be able to create tables. Okay, and we will be able to, if you want, you can create a table. We will be able to create a table. We will be able to, if we want to get rid of the table, we will say drop a table. Okay, when we say manipulate, we will be able to do all the kinds of data. We'll be able to select some data if we want to, something. We may be able to insert, delete, update. Those are all the operations you can do. Insert, delete, because that's mostly the operations you do. You find something, you want to insert something, you want to delete something, you want to update something. Okay, those are the things you can do. All right, what else you can do? Well, there are other commands also I'm not going to talk about right now. And there are something called indexes, constraints, views, triggers, authorization, transaction. So if we have time, we will be talking about transactions, which are very, very important. Okay, transactions are important in the sense that, let's say there are 100 people trying to buy the same seat on, let's say, going from New York to California, and it's very cheap, $50. Now the question is, how many seats we have and how many people we can sell to. If we have only 10 seats, we can only sell to 10 people. So if there are 100 people log in, we can't sell to 100 people. We have to make sure that they're only sold to 10 people. Okay? So when things are happening simultaneously, okay, then how do we take care of it? And that's very important. Okay? That's what the transactions come in. So there will be transactions, there will be constraints, there will be indices. Indices you need to get data, right, out of stuff. So indices, there will be constraints. We might be able to talk about some constraints. It depends. Okay, we will see. And then there's something called views. And there's something called triggers that you don't use now, but you will be using some other time. And also some authorization, because not everybody should be able to get to your data. You should need some authorization. Okay. All right. This is just some general ideas. Now we are going to be a little bit more specific. We're going to talk about bread and butter statement. So the bread and butter statement is just which I showed you before. Now I'm going to write it again. Select, let's say A1, comma, A2, comma, AN. Okay, this is what is going to be, oh, I want to do small n. Okay, all right. So what we are saying, select, okay? So this is what is going to be returned. This is okay. This is what is going to be returned. We'll see in just a minute. Okay, and then what you're going to get, where you're going to get this from? Well, you're going to get from these relations, R1, R2, Rm, okay? Okay, so these are the relations you're going to use. Relations. So this is your data, right? This is your database, from your database. I'll just call it data right now, because these are not all the relations. It's maybe just some of the relations. Okay? All right. Okay. And then we have something called where clause. Each one of those is a class, and where clause is going to have something called, we're going to call a condition. Okay, so what is this going to do? Well, this is going to kind of filter. This acts as a filter. Okay. All right. So this is going to filter everything. Okay. So let me just call this as a combined filter. What does that mean? There's a lot of data here in these relations, and we want to get only this one, but at the same time, we want to put condition on it. Okay. Say, for example, in our data we have, remember, we had a student. Let's see here. What do we have in student? SID. And we have student. All of you have this data. So remember, get that data in your GPA and high school size. Okay, and then the next one was college. So when you are doing this, you have college name, we had state, and then we had government. Remember, use that data which I gave it to you, okay? All right. And then we have here application or apply. Let's just call it application. So in the application, we had student ID, we had college name, and we had major, and we had decision. Okay, now we can ask first very simple question, then we can ask later. Okay, okay. Let's say that right now what we want is we want all students' IDs and names whose GPA is greater than, let's say, a certain number. Okay, so we want all students with GPA greater than 3.5. Well, how do we write it? Well, when we say we want all students, we didn't really make clear what the heck we want. Do we want students' SIDs or do you want students' name? Let's say we want both. So we will say here, select student ID, comma, student name. Okay. These are the two things we want. Now the question to be asked is this. This question you always have to answer it. Okay? Sorry. If this is our database and we are looking for student ID and student name, all those students whose GPA is greater than 3.5, where are they going to come from? How many relations we're going to use into getting that? Are we going to get this, this, and this, or we're going to use what relations we are going to use? We got three relations here, 1, 2, 3. Which one we are going to use? 1, 2, and 3. Which relations you are going to use? Roland, which relations we're going to use? We got three relations. Which relations we are going to use? This is the same question we have when we're talking about relational algebra.
Are we going to use 1 and 3?
No, because we are just asking for students with GPA greater than 3.5.
Okay, so we're just going to use 1.
You're just going to use 1 because all the data is right here. So although this is this is a declarative language, but it still requires you to know what are you going to data you're going to get from. So we can say here from student, and our condition is in where. That's the filter. Where our condition is that GPA is greater than 3.5. And you're going to put semicolon here or whatever, okay? All right. So anyway, right now I'm not worried about the function. You will, when you see the video, you will see that. Okay. So this is the simplest statement. Okay. Now let's assume that we need something and we need more than one relation. Okay. So let's assume that we want to find out, okay, a name of the students. Let's get here. Names of the students who were admitted to, let's say, computer science. Okay, now we see immediately that if we want names of students, they are going to be in over here. And if we want to find out if they were admitted or not, we have to go to the application. In the application, we have student ID. And then we have the major and the decision. So what we need is now student and application. So now, let me show you. This is in comparison with your previous, what you call, what we want is student name. Okay. Now, let me ask you this. Student name appears how many places when we talk about, okay, let me just say this first. We just want students' names who were admitted to computer science. Okay. So we know our answer is going to come from student and it's going to come from application. Do we need college? Do we need college?
No.
No, because the application has the college name. Okay. Now, we have to say a couple of things. We have to say where. Okay. The other thing is, first thing we have to say is the following. The student we are talking about here must be the same student here. Because there can be students here who never applied. Remember that? Do you remember that?
Yes.
So the student here must be the student here. So we have to say that the SID here must match this SID. So we have to say here SID. We have to say SID coming from, right? Okay. So, okay. So let's just write it this way so I can write this correctly. So we have to say student dot SID. SID coming from student must be equal to SID coming from application. Student.sid is equal to application.sid. What else we need? This is not the only condition. Because remember, this is a filter. What are other conditions? These students apply to SID, computer science, and they were admitted. So we have to say what? And. Let's just use the word and right now, okay? And major is equal to computer
CS.
science, right? Major is equal to computer science. And what? And decision equal to
Yes.
yes. Let's go over this again. So our answer is coming from the student and from the application. We don't need college. The college name is right here. If we want a college name, we can also get that here. So we want to make sure this student ID is the same as this student ID. Why? Because remember, referential integrity. There are people who did not apply, so we are not going to consider them. Therefore, we said student.sid is equal to application.sid. And then the other two conditions are they applied to computer science and they were admitted. Decision. Oh, I don't know what I wrote here. This is decision, okay? Okay. Any question on this? Okay. What about if we also wanted other things, right? So let's see. Let's see if we can look at other things, okay? Let's say we change the query a little bit. All right. So all right. Let's say we want to find oh, I think before I forget, I want to do something else quickly. Well, we don't have much time, but let me explain something. Okay. We have another condition here which we can use. In the case of where condition, we can use something else, and I'm going to show you what that is, okay? So that you know how to use that, okay? All right. We have, okay, so let me show you. All right, so we want to show another keyword called like. What the heck is that? L-I-K-E, okay? All right, so let's say we have different majors. We have bio major, we have biochemistry major, bioengineering major, and all that. Let's say you didn't worry about, you just want to find out if people were admitted to any major which have anything to do with bio, okay? So just started with bio, all right? Then how do we do that, okay? I'm going to show it to you. So what we can say that okay, all right. So we can say major like, for example, we can say bio, B-I-O. It doesn't really matter whether what it is. Okay, bio, and then I'm going to show you here percentage sign and close it. Okay, so when we talk about the like keyword, okay, this is a keyword, okay, like keyword. There are different options. Let me just show you quickly so that when you read it, you don't have a problem. Okay, so we have few symbols we use. Okay, percentage symbol. I just showed you there up there. Percentage. Okay, what does that percentage symbol mean? Okay, it stands for for sequence of characters. Sequence of characters greater than or equal to 0. So that means over here, when I say bio percentage sign and here quote unquote here, what that means is that it must start, whatever I'm saying, bioengineering, biochemistry, biology, whatever, it must start with the first 3 letters, BIO. After that, there can be any number of letters, 0 or more. Okay, so let me just write down the next one quickly, because then we will know nothing much there. The next one is an underscore. Okay, so the underscore it stands for a single letter. That's it. Okay, stands for a single letter. Stands for any single letter. Okay. All right, so let's give an example. Okay, here, if we say, let's say we say student just making it up, student ID, like let's say we are using some numbers. So you are using 6, 7, 8 numbers, right? So we can say the student ID begins with something. Okay, let's say it begins with S, begins with student S, and then we allow underscore 1, 2, 3, then I put 4, 5, 4, 5. Okay. So what does that mean? That the student ID, or like I should have put a capital. Okay. So that means the student ID begins with S. Then there could be 3 more single characters, anything, numbers, or it could be numbers, or it could be digits, or anything, or letters. Okay, so especially when you're talking about, say, social security number, let's try to write, people have social security number, let us say social security number, like, let's say the number begins with some letter. Okay, let's say it begins with 1. Okay, 3. Okay, and then we don't care what are next 2. Then say it begins with 6, and then the last 3 letters, let us say, we don't care what the next letter is, but the last 3 letters are 3, 2, 1. Okay, so what are we saying here? What we are saying is we are looking at social security numbers, which are like first 2 letters are 1 and 3. Then 2 letters, we don't care what they are, we match them. And then the next letter is 6, then next letter is, we don't care. And the last 3 letters are 3, 2, 1, okay? So this is, and we will look at more examples of this. So what we are really saying is that you have here what we call S like P, okay? And S stands for string, and P stands for pattern, okay? And I'll give you some examples more. We will look at them on Thursday. But I expect you on Thursday to have actually seen the video, okay? And put your data in too. Try to put your data in, okay? Okay, guys, please see watch the, not see. So please watch the video, okay? Okay. If anybody has any questions, you can hang around. Otherwise, I'll see you on Thursday. Now, Thursday, we might give you a quiz on exactly homework 11. Okay? And the quiz going to be towards the end of the class. So if you need extra time, you can use it. Okay?